Well, hello. Here we are, getting ready to tackle Chapter 1, called Making Buildings. Well, first of all, materials and methods is sometimes called building science. And so we're really talking about the science of building. This first chapter, Making Buildings, is an overview of the whole course in some ways, but they kind of focus more on process, things like the building codes and stuff. So let's take a look here. The materials are what we build with. We're going to be looking in this course at the different kinds of materials that we use, from wood to concrete, masonry, metals like steel, aluminum. There's high-rise buildings with glass windows, and they become structural. They become part of the outer cladding of the building. The properties of the materials, we'll be looking at those. There's different quality levels, and there's special standards on how we grade and rate different materials. And so we'll be looking at that too. We'll look at how we build, the methods, the tools, the equipment, how we make a building strong. We can brace a building with diagonal braces, and that works very well because you're kind of employing the shape of a triangle when you do that. But you can also sheathe something, so we'll be looking at that. And then, depending oftentimes on cost, if you've got more money to spend up front, you can make a building last longer and be more durable and need less maintenance. But if cost is the critical thing, then maybe maintenance is something that you can better afford to do on an ongoing basis. So that's the difference between maybe a fancy mansion with stone and brick compared to, and concrete compared to, say, siding that you might have on a Habitat for Humanity building. Okay, so hopefully you got better buildings than these ones. Okay, but looking at making buildings. So we're looking at dividing this up into about 5 basic sections, and some of them are more important than others for what we're doing. Learning to build is the first section. Then we look a little bit at sustainability. That's becoming more and more important in building. And then using different building systems, choosing them, some of the construction standards, particularly the building codes, and a few other things like that. Okay, so, just like the manufacture of automobiles, the construction buildings keep changing and becoming more advanced. The original log cabin had very few amenities. A lot of them didn't even have floors. And nowadays we've got houses that need communication wires running through them, not just electrical wires. Advanced plumbing, advanced HVAC systems, heating, ventilation, and air conditioning systems. So the mechanical and the plumbing and the electrical advances. Oh, and then energy efficiency, and that has changed things a lot. Every decade, efficiency becomes a new thing. So that's some of the things we'll look at along the way in a lot of the chapters, depending which material we're focusing on. There's different structural systems, there's different enclosures for keeping the cold out or the cold in. There's different visual qualities, durability, structural properties. There's economic differences, I've kind of mentioned these, and the environmental concerns of a lot of these different materials. For instance, one of the most exciting insulation products in the last decade or so has been this closed-celled insulation, spray foam insulation. But environmentally, there's so much outgassing. Oh, and then it's very, very flammable. So there's trade-offs sometimes. Different issues. Well, I want to kind of skip to through some of this stuff. Yes, there's soil conditions. We have to worry about that in Louisiana. We have very soft soil, and so buildings tend to settle. And so you have to think about your building is to make your foundation strong like a raft, so it can afford to tip and stay together and shift and sink without breaking apart. The vast majority of house foundation cracks come from just not putting enough reinforcing in the slab, or putting the wrong kind, or not having a deep enough perimeter grade beam system running around the outside or underneath load-bearing areas inside. There's different costs of labor and materials at different parts of the country. And so, for instance, up where I lived in Western Canada, cedar was cheap and everywhere. And so it was a very, very common building material. Here in Louisiana, it's relatively expensive. Meanwhile, brick is very expensive where I lived, where here in Louisiana, brick is relatively inexpensive comparably so anyways. And the thing is that brick is a really good durable surface on the outside of a house or other buildings. So in this environment, because of the bugs, because of the mold, because of the moisture. So let's see. Rigid frames, looking further down here. We can use, to make the building rigid, we can have walls, or we can have, with bracing and shear, we can have floor platforms as part of the building. That needs to be strong too. You know, when you take a box that comes in the mail from Amazon or whoever, it starts off, this package is all rigid, and once you slice it open, now it's all floppy. It's like that in reverse with buildings. In order for a building to hold together well from wind loads, from other forces, it's got all the walls and the ceilings, the floors, the roof, everything has to be tied together. And especially in this high wind climate that we live in, wind loads can tear apart a building, sometimes not by blowing it over, but actually exploding it by catching air underneath and picking up the roof and throwing it off like an umbrella. In some of the hurricanes, like in Florida, I remember Hurricane Andrew was the first time they really understood this and started changing the building codes. And that was, they had garage doors that just weren't strong enough. For here in the south with the high winds, your garage door, if it's not strong enough, it blows in, and then the garage ends up acting like a big windsock and inflates and tears the building apart, literally. And so brand new houses that were up to the latest building codes were torn apart in Florida, in Homestead, Florida, by a simple hurricane straight line wind that was, so the houses that had a garage facing a certain way were destroyed, and the ones facing another way where the wind wasn't blowing hard on, they survived. So zoning ordinances, the building codes, and various other regulations, we want to look at them too. So here's, first of all, we'll look at this a couple of times in this course as we look at materials, but there's three basic methods of making a rigid frame, to make the building rigid, like that Amazon box that you haven't torn apart yet with a knife or scissors. Now notice I put a pair of red asterisks here in my presentations, and therefore inside these videos too. You'll see these asterisks, pairs of asteri, I don't know, asterisks is okay. Anyways, you will see them, and that means when you see that's something that's going to show up as a testable question somewhere along the way. So just beware. These are meant to be there to alert you to how important this being more important. So three basic methods of making a rigid frame to stabilize a structure and make it rigid. You can have diagonal bracing, like you see in the left-hand picture. In the center picture, they've got a shear plane. If it's vertical, we call it a shear wall. If it's a horizontal floor system and it's rigid and it's holding the building together like a floor system, it's called a horizontal diaphragm. And then with welding particularly, the third point over on the right is where you have a rigid frame, rigid joints. And so with steel, you can weld and make two pieces of steel, a beam and a column, act as one, as if they were one solid piece of material, something that's harder to do with other materials. In some ways it can be done in site cast concrete, or especially if it's suspended slabs and stuff. There's ways of joining slabs to walls and stuff in pouring concrete. But again, that involves rebar, so it still involves steel. Okay, so let's see. So look at this framed wall. We're looking at a 2x4 framed wall that you might frame up to make a house wall. You got a window and a door. And in here we're showing you got a bottom plate and a top plate, and typically you have another top plate on top of that. So, but this, when you first shoot nails from the top into the bottom plate and into the top plate into the studs, that's not really holding this thing together well. It'll hold together well enough to stand up and move and place somewhere, but it is pretty floppy and pretty fragile. Once you put a diagonal brace in that, you can make that rigid frame so that it can't go side to side. It can't just flop over and fall apart. Or you can put sheathing, plywood sheathing, OSB, oriented strand board side sheathing on that wall with a proper nailing pattern. Now that diagonal brace could be a temporary thing nailed on the side, or you could let it in, as they say, where you literally draw some lines, trace them along there, and run saw cuts through there, dados we call them, so that you could set it into the face and leave it there permanently as part of that wall. We'll look more at framing in the second exam when we get to the second quarter of this course. But here's some plywood sheathing of some sort and a nailing pattern. And so the building codes will literally specify how often, what kind of pattern around the perimeter of the plywood sheathing, or whatever kind of, if it's an OSB sheathing, a lot of the wafer chip board that you see paneling on houses that are new that they're building, when you see that happening, that's called oriented strand board, or we call it OSB. Now, a lot of what you will be learning in this course will be terminology, the vocabulary of construction. You know, if you're going to read some plans, some specifications, and bid a construction job, and estimating is a big part of construction management, you've got to be able to understand the words you're reading enough so that you don't make any mistakes and underbid or overbid a job. And so, yeah, the vocabulary that you learn along the way will be important. So if it's a vertical wall like this, then we would call it it's called a shear wall. If it's horizontal like this next picture, then it's called a diaphragm, a horizontal diaphragm. And so that's part of engineering speak. It's, talking about structural engineering and understanding this. But here's the thing, as a construction manager, you have to be able to speak with engineers, architects, you have to be able to speak with customers, you have to be able to speak with the workers, you have to speak all the different lingo and be able to communicate. You're the great communicator when you're a construction manager. You have to be able to deal with everyone because you're the one getting the job done. So, yeah, this is a floor system, but when you put that plywood sheathing down with a proper nail pattern on it, you make that floor rigid now and it becomes a critical part. You know that on a typical concrete basement wall, those walls are not strong enough to support the dirt, the backfill, until and unless you have that floor system installed on top of that wall, because that's what braces the top of that concrete wall. So it's an important structural element for a concrete basement to have that floor system installed. You're typically not allowed to backfill that concrete basement wall until you've got that floor system fully installed and inspected. Rigid frames, you look at this ugly, maybe kind of semi-ugly weld anyways. It's not a bad weld, but structurally, how pretty the weld is not so important. Is that the weld is a deep penetration between the two metals. So oftentimes structural steel buildings will take steel members, beams, and columns, will bolt them together initially, and then you'll come back for at least some of the joints like this and weld them, a deep penetration weld, top and the bottom of the I-beam, for sure, and that sort of thing. We'll look at structural steel later on in this course when we get to the to the last quarter of this course. Anyways, so here we're looking at a basement wall, and you see the connections are a big part of it. My dad was a structural engineer, and he would always tell me that what makes most buildings and structures collapse is a bunch of failed connections. Somewhere along the way, either the engineer under-designed and didn't specify enough connections, or just as often, it's the contractor who cheapened or got lazy or didn't think it was all that important and didn't use the right connections or enough of them. So just realize that as you're building, you could be the cause of people getting killed if the building comes down if you're not focusing on making sure that you're using the correct connections. So when we're talking about connecting from one kind of material to another, like in this case, we've got to connect concrete to wood. And in order to get a good connection, so you can actually, for it to work, you got this sill plate. So that sill plate is what allows you to get a good connection by those anchor bolts. Now there's other ways other than anchor bolts. There's metal strapping here in Louisiana that we'll use in the South when you got a slab on grade that you can use to hold that wall down, because you're not trying to brace a foundation wall like this. No basements, but in a basement you typically need anchor bolts at a certain pattern, and what they're trying to show, I think, is the idea that you ideally put the studs where they won't interfere with, you put the bolts where they won't interfere with the studs. Once you've got the frame that you see here, then plywood sheathing helps continue to make it a diaphragm. But that whole wall system has to be connected, typically with metal plates, Simpson strong tie plates, from that wood sill up to the trimmer joists that you see going around the outside here, and then the plywood with a where you shift the seams so they're not all in the same place on the plywood with a proper nailing pattern. And typically they're glued and nailed, or most often nowadays glued and screwed down so that they're really rigid and they won't squeak over time. Okay, so looking at sustainability for a little bit here, the building codes are adding more requirements for sustainability, so that's coming down the pike in that way. And then there's other entities that are pushing for the materials to be more sustainable in that respect. So, there's a huge environmental impact of buildings. They're responsible for about a third of the world's energy use and associated greenhouse gases, about a third of the U.S. energy use. Electrical consumption right now, it's been about 2/3. I guess that will change more as we have more electric cars charging at home. But that dynamic, 30% of the U.S. raw materials consumption, 25% of the harvested wood. And by harvested wood, that's really what we try to do nowadays more than we just used to go in forestry and take down whole forests, and then they wouldn't grow back properly because the soil erosion would happen before you could ever get a forest established there. So smarter foresting is where they don't take all the trees out. The trees help to hold the soil together and keeps the sediment from just running off and flowing away and ending up in the water system and clogging up our rivers and such. So yeah, about 1/3 or maybe of the energy use and such, but the greenhouse gases is getting to be more like maybe 40%, which is not quite 1/2 the way that it says here. But anyways, so here's a thing that could be turned into a testable point. As you see my red asterisk pair there. So sustainability, my definition of sustainability is you are meeting the needs of the present generation without compromising the ability of future generations to meet their needs. So that's what you're trying to preserve when we talk about sustainability. So how do we accomplish this? Well, yeah, you can reduce the depletion of fossil fuels, minimize the use of valuable productive land. When they start building houses on land that should be used for farming, that's a problem. Protect the forests, and so again, I notice up in the area where I grew up, we have so much land that's in forest mode. British Columbia, where I came from, is nowhere near the biggest province in Canada, but it's 50% bigger than Texas, and it's all trees pretty much. You protect the water resources, minimize air pollution. All these things are things we'll have to deal with at some level or not. And I just want to show you where that's coming into the construction industry for green building. You can have a building that an architect will specify that you have to do such and such toward green building. There's other lesser things that have creeped in on the building codes that kind of require you to prove that you are building in a green way at some level. And so there's some training that you'll want to take at some point. The idea is that if we track and pay attention to sustainable building construction through all the phases of the life of the building, from cradle to grave, from building the materials themselves to creating the materials in manufacturing and sawmills and concrete, Portland cement factories and such, to when you're tearing down a building and maybe grinding up the concrete so that it could be used as an aggregate material, again, as a recycled material. And that's a pretty practical, and it works. It's particularly practical here in Louisiana, where we don't really have good material, good rock to make concrete out of. We dredge the river to get whatever Mother Nature rolls down the river and collects in elbows. Well, so we get random gravel. We don't get gravel that's necessarily to a specified strength. So when you can use concrete again for maybe at least the foundation, the roadbed underneath the road, that can help. So there's this specification called LEED, L-E-E-D, Leadership in Energy and Environmental Design. And it's a standard that is partially adopted by the building codes currently. There's standards for existing buildings, there's new buildings, there's commercial buildings, homes, and so there's different standards depending on the use of the buildings, basically. But so you can get LEED certified, get training in LEED building. Typically, commercial construction companies run into this more than any other company. And so the commercial construction companies tend to want all their construction managers to be LEED certified so that they know how to bid a job when there's strong LEED requirements. And that's typically when there's an architect involved. But government buildings, buildings where there's high-profile buildings, they will tend to do much more than what's required for bragging rights. And then other aspects, they're part of regular building at some level. So, just let me skip along a little bit. Here's an example right here where you basically have a point system in LEED where you've got to get 10 points. Well, you pick from the list, or maybe you need 5 points, depending on how stringent the project that you're on. And so you can figure out how to make sure that and document that the materials that you're obtaining were partially recycled or all recycled and that sort of thing. Certified wood, for instance, down there at the bottom is about using wood that has been responsibly grown, which means they really turn it into a harvest where they can grow the trees, and as they take out the trees, they can plant right away and turn it over like a crop. So there's the basic, which is LEED certified level down there, 40 to 49 points that you'd be collecting in order to be under that category. And a lot of the building code requirements are getting us to that level. Then there's silver, it goes up higher, and then gold, and then platinum. So I had the opportunity to watch and take pictures for 3.5 years of the construction of the main library here in this middle of the city. And they were a platinum project, and so there was a lot of LEED requirements in that project. Assessing green buildings, there's other systems besides LEED out there. The National Association of Home Builders has green home building guidelines, but a lot of them are dealing with green building that comes from that LEED certification again. So a LEED is kind of the critical area. If you look inside our construction management information hub called CM Connections, under some of the training, I've got some information there from an instructor that offers an online version of that training, something that you could consider taking, and they have a special discount for students. And then down at the bottom on this page, you got the International Green Construction Code, IGCC, where you see they use the lowercase g. That's part of the building codes that we use in this country. So that's the Green Construction Code. It's the entity that creates and manages all of the building codes that we use here in Louisiana and across almost all the country. That organization is called the International Code Council, or ICC. And so that's part of our focus, a significant part of our focus here is just talking about the building codes a little bit here. So we'll get to that a little. Oh, one more point down at the bottom of this page is passive house is another green energy energy construction method or code. It comes from Europe, and I think originally from Germany, and that's kind of where the root words come from there. So the thing is, you'll find that super energy efficient housing, when people do it, they like to go for bragging rights of following the passive house standards, even though they're not directly used in this country. They are certainly can be used, and because they tend to meet and exceed the other standards we have here. So looking at the building ordinances, the building codes, and other regulations here, you have to control land use. And you say, I don't want anybody to control what I use my land for, but you really don't want to have a factory next to your school making all kinds of noise and smoke and who knows what. You don't want to have a nightclub next to your house. You can't sleep at night if there's too much noise. Okay, I'm talking about noise here, but other land use issues. You don't want a great big warehouse next to your house either. So it's like residential use needs to be kind of separated away from industrial and commercial use to some degree. And yeah, there's different kinds of and levels of commercial use too, but some areas of the country go to have much stronger rules on land use, and their land tends to become more expensive. And generally here in the South, we have less rules on land use, and so our land is less expensive because you tend to make land more expensive when you restrict what it can be used for. But so that's a side benefit or negative, depending on your point of view. But everybody knows and agrees that you need to have some controls on use of land, so that you don't end up with a big ready-mix concrete plant right next to your house or next to your business with dust always dusting your cars and everything else. You try to keep these things separate from each other so that everybody can play nice. So the building codes primarily regulate health and life safety, things like fire safety, emergency egress. Egress, that's those pretty white birds. No, that's egrets. Okay, so a bad joke. But the emergency egress, you're talking about the ability to enter or exit, and usually it's more about the exiting in an emergency. And so when you have a bedroom, you have to have two ways out of that room. Either have two doors, or you have a door, which is normal, and a window, which is normal. And so that window has to be something you can get out of in an emergency. They also regulate construction quality, so they will be and structural integrity and the durability and livability of the building. So there are things that they test for, including making sure that you've got proper insulation, that you've sealed the building up, and those kinds of things. Nowadays they'll actually pressure test your house to see how leaky it is, and so you don't pass that inspection, you don't get your final occupancy permit. And that's something that never happened in the old days. Houses were meant to breathe, we say. Well, energy costs and such have made us think that through a little differently. Okay, so this is an important page, as you see all the pairs of red asterisks. In the United States, well, really since 2000, the International Code Council was created, and for Louisiana, after Katrina, in 2006, 2007, in that region, we pivoted over and started using the International Code Council's codes. That's for the commercial code, it's called the International Building Code, or the IBC. So you need to know these abbreviations: the International Code Council, ICC, and the International Residential Code is the IRC for residential construction. Now, there's some other codes that used to be used all across the country, and the problem was we had several of them. And so if you're a company that's working and building and bidding jobs across the country, you had to try to keep track of lots of different kinds of codes. So this standardization has helped make things a lot easier for construction companies that are building in various places, that they can use one code. And yes, there'll be regional differences, but you read about that and you see those things explained and spelled out in one system instead of all the several that were running across the nation. I think one of the last holdouts is actually California in moving to this system. And it's because they had special needs that needed to be addressed with earthquakes that they really needed to address. So they had a reason, but they're coming on board. So the IBC and the IRC, you need to be familiar with that abbreviation, what they mean. And so, yeah, the IBC is for the commercial building, for building everything except for residential. And then the IRC is for residential construction. So what does the IRC cover? 1 and 2 family homes, that's single family dwellings like a typical house or a duplex. Or townhouses. Well, that sounds strange. Hey, that's a bunch of buildings together. Why would that count? Yeah, only when they really are truly townhouses, when they're side by side. The whole thing is about egress, safety, life safety in an emergency, getting out of the building quickly. And so you can have them touching each other on the sides with a firewall system that's going to be specified in the code. But you got to be able to get out through the front and the back of that building. Oh, and if your house is more than 3 full stories in height, then you have to use the IBC, the regular building code, the International Building Code. So again, the IRC is the International Residential Code for residential construction, and the IBC is for everything else. It's the International Building Code, the IBC. Okay, so that said, within the IBC, we have different occupancy groups. And so assembly could be something like a big theater or even a church. Those are assembly buildings. And so when you get a whole bunch of people close together, it takes time to get everybody out in an emergency. So you need more egress, more emergency exits. Business, you've got people coming in and out of a business and they're focusing on their works, and so those needs will be different. Educational, and they can be combined together too. You can have more than one code for a building, but it means that you have to build to certain specifications. So look over here at the top of the second column on this page, institutional. So if you had people in a hospital that maybe can't escape because they're bedridden, well, it's going to take longer to get them out. So the buildings that are institutional have to be made primarily of concrete. And you say, what about steel? Well, you can use steel, but steel does not fare well in a fire. It fails. That's how the Twin Towers collapsed. They were steel buildings without proper fire protection. They had inferior fire protection. I can talk about that more some other time. But so another institutional example would be jails. When you're captive in there, well, then when it comes to egress, you got to make those buildings so they can't burn in any way, shape, or form and cannot fail in a fire. Whereas a utility, that U category of utility down at the bottom of that second column, that's something for a warehouse or something. Storage would be in that category too, and so they wouldn't require the same kind of stringent things. You could build a steel building with no fire protection for a storage building because it's only being occupied by stuff and by very few people. Nobody's living there either. So that's one aspect. The other thing I want to talk about is, you see my asterisk, this is more important, and that is we talk about construction types. We use these Roman numerals 1, 2, 3, 4, 5, 1 to 5, but of course they're in Roman numerals, so they're I and II and III and IV and V. But yeah, type 1 through 5. And so type 1 is the most fire resistant. Most resistant to fire. Concrete and steel. Actually, I should say concrete and protected steel. How do they protect the steel? Well, one of the best coatings has been asbestos. That was part of the problem the Twin Towers had, is that they were discovering that asbestos was dangerous, and so then they stopped using it part way up, and so they end up with an inferior product. The Empire State Building, though, built in 1929 and 1930 and such, somewhere around that area, encased the steel building in concrete. So concrete can be used to protect steel too. As you go down the list to the bottom, the least fire resistant is type V or type 5. And that's because it's basically wood light framing, wood light frame construction. So framing up a house, it's okay. Residential construction, you can use type 5 construction. For institutional buildings, you've got to use type 1, and everything else is somewhere in between. Now, the heavy timber type 4, IV, there, is a special case. Yes, it's better than type 5, just by order, but it's actually better than some types of type 3 construction, because a great big heavy wooden beam takes a lot for that to burn through. It has a certain burn rate, and so that's why you can have a great big heavy beautiful looking wooden beam in a church and it's fine, because it will take a long time to burn through that thing, and so the egress is not a problem there. You can find lots of examples of buildings where there's wood and steel together, and the steel will be drooped over the wood. The wood stayed up. Yes, it burns, but it takes time to burn through it, whereas the steel conducts temperature quick, and once it gets up to 500 degrees, it's lost half its strength. By the time it gets to 800 degrees, you've lost 90% of its strength. And most fires are much hotter than that. So, yeah, there we go. Let's see. So there's a certain burn rating for the construction and stuff in here, but I don't need to get into that too much. There are things that you can do, as far as there's limitations on how many square feet you can have per floor of a building in the building codes, on the commercial building codes, unless you do certain things and one of those things is that you got number of stories, height and feet, area per floors, that when you go and start using sprinkler systems for fire retardants, to snuff out fires, you're allowed to have more square feet per floor. And so that is, in other words, many cases they don't require sprinklers in buildings, but they will. But if you want to make your building bigger, then you will. So then you are required, and so it's one of the ways they deal with this. Adding sprinklers to a building allows a 400% increase in allowable area for a one-story building, or a 300% increase in allowable area for buildings greater than one story. Interestingly, in 2009, you see that last bullet down at the bottom, the residential code, the IRC, prescribed using fire sprinkler systems for all new homes. The last time I looked, it was still basically California and a few communities in the Northeast that were doing this. But actually, that's maybe not quite true. You can find certain neighborhoods, even in Louisiana, where they will specify them in their neighborhood rules, which are the neighborhood association. Their rules become another level of governance where they can have those kinds of rules. Because what happens is the building codes are not law anywhere by themselves. The organization, the ICC, has no power over anyone. This is all a consensus organization. And what happens is we take, in each local community, will adopt them, and they don't always adopt everything. So you can find that maybe certain rules are enforced in one area that are in the building codes and not in another. And it can happen statewide, it can happen citywide, and it can happen in neighborhood-wide. There's other design constraints like accessibility features, like the American with Disabilities Act, and requiring in certain kinds of buildings that you have ramps so that people in wheelchairs can get up them, and people that have a hard time walking stairs can go up the ramps, and that sort of thing. There's also OSHA for building the structures in particular. And if you're building a workplace, then OSHA there can be constraints. That means that how you design the building for the people that are going to work in the building might matter too. There's environmental regulations from the Environmental Protection Agency on emissions of air pollutants and water, soil erosion while you're doing the construction. So you've seen in construction sometimes 1-foot high silt fences that are just keeping the wind from blowing the dirt off the property When you've stripped all the topsoil, you've got nothing but dirt. It gets dry enough, then it can blow off in just a big dust storm, and you've or run off in a rainstorm into the city runoff system and clog it all up too. And then the insurance industry has a lot to say about how you're going to build, dealing with flood zones, dealing with wind, building in a high wind area, building in an area where there's fires, forest fires and earthquakes, all of that. The building industry, how do they have say? Because, if you build a certain way and they don't like it, they don't necessarily have to insure your building. So if you want your house, your building, your business structure to be insured, then you've got to make sure that you're following, their requirements too. So there's a lot of rules and regulations that go into building anything in this country. And so ASTM, you see the asterisks here, initially, and for most people, we still would say that it stands for the American Society for Testing Materials. They've added the word international because they've tried to branch off and become a standard everywhere, and they certainly are in Canada, for instance, and I think in other countries. But they are a major consensus organization for materials and methods standards, and so you will find that there is a standard number for tests for filling doing a slump test. There's an ASTM standard. We'll look at that in the concrete chapters. There's an ASTM for filling a concrete testing cylinder. There's ASTM standards for testing asphalt and after it's paved or beforehand and stuff. So materials of various kinds that there are standards for. There's also some, particularly with equipment, there's ANSI standards, the American National Standards Institute, ANSI, and they have certain standards for materials and equipment, particularly safety equipment, but also others. And of course, mentioned the building codes and such, but there's also standards for in other ways, and I had one in my head and I've forgotten it. Now, there's also trade organizations and professional organizations that have certain standards that we use or follow. So the American Institute of Architects, they have maybe their most famous contribution here would be how a contract is written for a construction contract. And so typically most contracts that you will sign or create and sign and such will follow the format of the American Institute of Architects. The specifications for drawings follow the Construction Specifications Institute standard called Master Format. So yes, it's abbreviated CSI, and yes, it existed long before the TV show. The American Institute of Steel Construction, when we get to structural steel, that will be important. They specify all the properties of every structural steel member. They have this manual they call the Steel Manual. The entity is affectionately called AISC, the abbreviation for all this, by structural engineers. And so an AISC Steel Manual is an important thing for every structural engineer, civil engineers too, to some degree. A structural engineer a structural engineer actually is a civil engineer. It's a special kind of engineer, but a special kind of civil engineer. But anyways, so in many cases, other types of civil engineers will also have that book. The point is that if you need to know how heavy a member is, if you need to know other properties of it, this is the authority manual. And so these are standards that are used in the industry by everyone at some level, and yet they're by private organizations, so not everything is a government organization. And it still becomes important. So that CSI standard is called Master Format. It's a way of organizing the construction drawings. And so the order of the materials and how they'll list in the specification, you can go to Section 5 and always find the steel section, and within there's subdivisions too. So nowadays there's 50 major divisions. There used to be 16. So if you're looking at older drawings, that's kind of important to know. And so some of those moved around a little bit and some of them stayed the same. But here's where it comes back for you in a daily way as in your career in construction management. Besides reading drawings, these divisions are also used by estimating programs. And so the way everything's organized in your estimate and such will typically follow the more master format thing. You'll see more about that when you go into the blueprint reading course. So here's just an example under showing you some of these divisions, not all of them, but some of them. And so they kind of put them in the order that you would build a building in. They start off looking at general stuff, the general requirements, existing conditions, the site work that would have to be done, the excavation would be all under Division 2. And then you got to have a foundation. That typically means concrete and or masonry. And there can be, so they kind of move down the line. But anyway, so, and then, just looking at a little specialty area here, you deal with Division 5 and metals, but if you're going to have a whole building made of various kinds of steel, you may need all the kinds of subsections within it. And so they do exist if you need them. Okay, so master format is going to be an important thing mostly for, I wanted to mention it in here because, because it's part of these systems of organizing that we use in construction, but you're going to be learning a lot more detail than what I just talked about here when you go into the blueprint reading class. So useful links. I've had some of these presentations. I had some of this from the author of the textbook that I based this course on, but I don't make you buy the textbook. But, you have an essay to write for this course, and so you could consider looking at Iano's Backfill blog because you can find some really interesting things to write about in there. So, and then Fine Home Building, if you're looking on the residential side, is one of the best sources for information, cutting edge information about new construction techniques and stuff. And by the same company, same entity as Green Building Advisor, and it's a website and a subscription, but you can get a lot of information without a subscription for either one of these. But the Green Building Advisor works at the cutting edge of energy efficiency. So there's all kinds of issues that come up, like OSB, that wafer chipboard. It turns out it's not such a solid material. Some brands and some types of that stuff are not sealed up well enough, and so air can blow through them. You tend to think you put a board up, you've got a solid surface, and that's not the case. And that was first brought out by these people in Green Building Advisor. Anyways, so how do you like that building? It's over on the wrong side, hey? So here's the thing. It cleanly came off the building, probably from an earthquake. But the point is, that's not supposed to happen. The buildings are supposed to be tied down, not just sitting on top of a foundation. Some of the old houses, the pier foundation houses, some of them are just sitting there, and they could be picked up by a tornado or hurricane, can literally launch it like the Wizard of Oz style with Dorothy in the house and all that. But it's not supposed to happen. That's not the way we properly build buildings. They're supposed to be anchored down to the foundation so they can't be picked up, they can't fall over like this. Anyway, so that's a good enough treatment of that course. We'll go this particular chapter, So let me go and stop that and talk to you next time.